Well, welcome everyone. I always forget how long it's going to take to set up YouTube live here, and so I'm always behind on that. So I'm sorry about that. So the snowstorm hasn't hit yet, so here we are. Let's see. It seems like we had briefly talked about this and how if you go throughout the United States, there are a lot of different aquifers and watershed systems throughout the United States. The big one that we focus on here in West Texas is the Ogallala Aquifer that's right here in the middle. But someone I think on Monday mentioned the Dockham Aquifer as well, right? The Dockham is, if I'm not mistaken, this purple aquifer that's right here. And you don't see part of it because part of it actually underlies the Ogallala Aquifer. So if you're digging a well or drilling a well, you go down, maybe 200 feet and you're in the Ogallala Aquifer. And then you keep on drilling, you drill down through the bottom of the Ogallala Aquifer, you keep on going. And depending on where you're at, maybe several hundred feet to even more than 1,000 feet, you're going to hit the Dockham Aquifer. And in places, the Dockham Aquifer, the water's pretty good, but most of the Dockham Aquifer is pretty salty. So you're running into two major issues when you're trying to pull out of it. Number one, it's a lot more expensive to pull out of it because it's a lot deeper. And number two, it's a lot saltier, and you start running into all kinds of problems when you start pumping salt water into an agronomic situation. You're essentially going to cause yourself many times a lot more problems than you're going to benefit yourself. And then I was wrapping it up and saying, we used to think that the Ogallala Aquifer was this inexhaustible water source. It turns out, relative to West Texas, that's not the case. Up in Nebraska in particular, they have a lot more recharge going in simply because they have a lot more waterways that actually feed into it. And so they balance the irrigation demand out of the aquifer with the amount of precipitation that they're getting, or the amount of recharge that they're getting into it at that point. So their goal is to maintain a stable water level within their aquifer. Our goal is to try to mitigate the effects as we're gradually running out of water out of the aquifer. But one question that has come up is, there's water still percolating down from the surface that's going to end up in the Ogallala Aquifer in West Texas. But how long does it take for water to percolate down through the soil system and to actually make it into the aquifer? Anyone have any ideas? It's anywhere, it's been estimated for the shallowest aquifers that maybe the shortest amount of time is maybe about 20 to 30 years. On average, it's probably more like 150 to 200 years. So really, you see some level of recharge into it, but the reality is that recharge that's coming in, that water actually entered the system potentially several decades to even several hundred years ago, and it's still feeding down into the system here. So we're working off of the expectation in West Texas that, the aquifer is going to continue to decline over time, and you work within what you have. We talked briefly about 5.5 million cattle enter, West Texas on a given year. I thought it would actually be interesting. I pulled the most recent cattle and calves inventory I could find for the USDA. And you can see you've got a bunch of cows and calves up in this region of Texas here. And in fact, throughout Texas, you've got a lot of animals here. So every dot is 10,000. So on the exam, I will show you this, and I will have you focus on an area and make you count the number of dots to figure out how many. I'm joking, but as you can see, you've got these regions right here in West Texas and on up into Oklahoma and Kansas, where you've got large quantities of cattle. Some of them are on range, but a lot of these are feedlot animals, because this is really where the industry's driven here. So if you're in a pasture situation, the goal is to minimize your inputs into the pasture system. And if you've got everything set up so that it's balanced, everything, when it's in balance, more or less works together. So your goal is you have the animals to harvest the forage. So they're walking through the field and eating the forage. They're controlling a lot of the weeds that we tend to have that tend to be competitive with grasses in an undisturbed environment. So help me out, Jill. When I say an undisturbed environment, what would an undisturbed environment look like?
Probably like no non-native plant species in the area.
Okay, potentially no non-native plant species in the area. That's pretty good. You can pass it. And let's see, it's Peyton, right?
Yeah.
Okay. What do you think of as non-disturbed, Peyton?
Maybe like humans haven't had a chance to go in there and plant plants that they want in there or something.
Okay, so humans haven't really stepped in there. You can pass it now. Boy, I shouldn't have sent out the email yesterday saying that if the roads were bad, don't worry about coming in. Many people have been proactive in their decision making on the bad roads, which is fine. I'd much rather have people safe than anything else. But both of those answers move around the concept of undisturbed means that we're not influencing it. However, in this particular case, undisturbed simply means that you don't have any mechanical or chemical things going on to affect it. So let's say you've got for example, near our old house in Wolfforth, they're getting ready to put in a bunch of houses. And they came in, they cleaned everything up, got it ready, and then they parked all their equipment for about 6 months. And weeds came up in places and whatever. During that period of time, it was undisturbed because they didn't have anything going on in there, and essentially they just turned it loose and whatever wanted to grow grew. Some weeds do really well in those environments and some weeds don't. And so you can actually, by having cattle in there, they'll knock down some of these weeds that like to be in a place where you're not having any inputs at all. So they eat the weeds. One of the other nice things is they spread seeds, which for weeds may not be a good thing, but if you've got a forage grass or a forage legume that's gone to seed, if that cow eats it, she's going to move that somewhere else in the field, and essentially you've got a natural way of propagating those plants to other parts of the pasture here. So that's good. I guess that brings up the question, how do they spread fertility?
Going number 2.
Okay. Yeah, you're half right. They also do it by going number 1. Good answer. So they spread fertility through natural processes. But the nice thing is that you've mostly closed the loop in terms of the fertility within the field, because you've got to put nutrients into the soil for the plants to grow. The plants take up those nutrients, but because the plants are eating them and putting most of the nutrients back into the system, you actually have relatively little loss of nutrients out of the system. So your step one is let the animals and let the forage grasses do as much as they can. And you just, if things are in balance, don't do anything to upset the balance and you're in good shape. So that's target number one. Number two, especially with legumes and other forbs, a lot of them over time are going to tend to decrease in number just because grasses tend to be pretty vigorous within a grazing environment. Some of your other forbs and legumes are not as vigorous. Some of your legumes, animals really like them, so they'll actually go through and they'll pick and they'll eat some of the plants out of the system, and they'll tend to leave the others until some of the plants are more or less eliminated. So a lot of times what you'll do is you'll come in and you'll overseed and do some of these things just to maintain the balance that you want within that system. So number one, let the system do as much as it can on its own. Number two, do what you can to, keep the balance the way that you want it relative to, what animals eat isn't necessarily going to maintain the quality of feed that's going to benefit them long term, because animals are not forward thinkers. They're going to eat whatever tastes best by and large. And so your goal is to balance that out so that they continue to have high quality forage out there. And then finally, sometimes you're going to get into situations where you're not going to be able to correct everything just through the use of the animals. Come in with fertilizers and herbicides, bring it back into balance, but the goal is to only do that in cases where it's not going to be able to rebalance itself. And then, the goal is, this brings up an interesting question. So what happens if you overuse fertilizers or herbicides? And this could be a number of answers. It could be environmental answers. It could be answers just in terms of the management. What are some of the issues that you can run into if you over apply fertilizers or over apply herbicides?
The plants could die.
Okay, the plants could die. Good, you can pass it. What else might happen, Eric?
You could burn it with some fertilizers.
Okay, you could burn it with some fertilizers, certainly. All right, go ahead and hand that over. Let's see. It's Peyton?
Yes, sir.
Okay, so Peyton and Peyton. Okay. All right, so Peyton, any other issues? Are there any risks to the surrounding environment if you over apply fertilizers or herbicides?
It could leak into nearby water sources.
Okay, yeah, you could get off target movement of these things. So your fertilizers, if they enter a water system, you can run into major problems. Now, West Texas, we don't tend to worry about that as much because you don't see a lot of rivers running through Lubbock, and it takes a long time for things to move down through the aquifer, and the soil tends to be a pretty good filter of that. But one of the major issues that they've had, for instance, in the Mississippi River Basin is over time, off target movement of, in particular, nitrogen and phosphorus fertilizers has caused a lot of problems with algal blooms and with what's it called, hypoxia, when you don't have enough oxygen in the water. And these have been caused largely because when you get runoff and off-target movement, when you've got stuff where you don't want it, you tend to have things grow that you don't want to have grow. And so that's one of the major issues right there. Go ahead and hand it to Elizabeth now. Any other issues that you might run into?
Loss of profit. If you
Okay.
use too much.
Yeah, if you're inefficient, you're essentially paying money for something that isn't benefiting you money-wise either. So all of these are issues that you can have if you're over applying these. And a couple of the other issues that I've seen, and I've seen this more with pesticides, but you also see this with herbicides as well. when you get locked into applying herbicides and pesticides on a regular basis, sometimes you're going to take out things that you don't necessarily want to take out. And the things that you're trying to control over time are going to have a tendency to build up either a tolerance or resistance to those management techniques. So the big risk is that, you know, not only is it cost inefficient, like Elizabeth just said, but it also is going to cause you problems down the road in this case. So largely the goal is, you know, these numbers are important in that, you know, priority 1 or target 1 is let the animals do the work. Priority 2, you know, reseed as necessary. And priority 3, use these fertilizers and herbicides to get things back into balance, and then step back and let the animals take care of it. A lot of times your goal is to do some of this maintenance early in the season, you know, before the crop is actively growing, and your goal is to let it kind of run through the year without having to do a whole lot of babysitting on it during that year. All right, so that's Texas really quick. Let's jump over to the US and the world real quick. I'm excited about this a little bit because it starts to get into physiology and starts to get into water consumption, which are things that I have some experience with. We'll talk briefly about adaptation by climate based on precipitation and temperature. We'll talk about some of the types of forage species and some of the challenges and strategies that we have. So here's our typical world map here. This is a vegetative map, and the darker the green, the more vegetation you have. The brighter or the whiter you get, the less vegetation we have, which is really funny that Greenland is more or less white and Iceland is more green. Again, you know, the vicissitudes of the language. But the region of the United States that we're most focused on in this class is this region right through here. I don't think this will, yeah. All right, hang on a second. You will start to rue the day that you see me go into Microsoft Paint in this class, I promise. Let's see. Why doesn't it allow me to adjust the size here?
Click brushes.
Okay. Ah, wise man. Okay, thank you. Let's see. Is it Brooke? Okay, so.
You might want to change the color to not yellow.
Well, I kind of like yellow. It's camouflagey. Yeah. Okay. Let's see. What goes good against green, yellow, and orange? White? Yeah, white. We'll go white here. Yeah. Okay. I guess I could have used the pen, but I decided to do it with the mouse. All right. Brooke, what does that look like? Yeah, looks kind of like Bevo, doesn't it? Because it looks like a cow that fell on its head one too many times when it was a calf. All right. That's actually not where I was going with that, but I couldn't resist given the opportunity. So imagine this as a region rather than as a cow. Is this region wider at the bottom or wider at the top?
Wider at the top.
Okay, it's wider at the top. So it acts kind of like a funnel, doesn't it? Isn't that strange? Okay, you can pass it now. So that brings up the question, I suppose. Why do we care? Well, there's actually a reason that we care, and we'll get into it in a second. But the region of the plains of the United States tend to follow this funnel pattern where they're wider at the top and they're smaller at the bottom. And yet, if you look at the general rainfall patterns in the United States, well, what were the general rainfall patterns in Texas? If we were drawing general rainfall patterns in Texas, what would they look like?
Isn't West Texas like 18 to 22?
Yeah, West Texas is 18 to 22. So let's see, let's change this to black and I'll change the size smaller. So West Texas is about 18 to 22. As we go to the east, does it get greater or less? Okay, so you've got another zone here. Does it follow more or less a straight vertical line in Texas?
No, everything seems to flow more east.
Okay, yeah,
southeast.
so the further east you go, the more rainfall you get, but more or less, if you go north and south, it follows pretty similarly other than the coast area. So, if I was doing rainfall in West Texas, I could just about do a few vertical lines here and start in El Paso and say dry, and in Houston and say wet, and everything in between is some gradient between dry and wet in there. So in the United States, particularly in the plains, more or less it follows that same general pattern. So wouldn't you think by that this pattern here would be more, well, here, wouldn't you think it would be more like this, which is more the pattern, right? Less the pattern of Bevo and more the pattern of the jail cells that the Texas football players tend to end up in January and February of every year. So be thinking of that. Why do we get this funnel shape in terms of the land classification, even though we've got a vertical rainfall classification here? All right, good. You can pass it now. Assuming I can find my slide set again. If I'm ever unable to find my slide set again, everyone just get up and walk out and leave. And I think it would be kind of funny on video to have that happen. Oh, I'm not sure if I have my camera on here. Hang on. Oh, no, I do. Okay, so some of the things that affect what grows where are going to be the precipitation, but we also have things like temperature, wind, the amount of sunlight we get, and the variability is important. I told y'all the statistician's joke on Monday, didn't I? So the variability is important. Also the soil properties, which are not entirely the same thing as the climate, but they're closely linked to the climate as well. So help me out here. Why would soil properties be somewhat linked to the climate?
Because like places where there's like higher rainfall, they tend to have more fertile soil.
Okay, good. So for example, if you've got higher rainfall, you're going to tend to be able to grow more vegetation on that soil just because, plants need rainfall to grow. Also, over long periods of time, for instance, I came from the coastal plain in Georgia before I lived here. The soils there tend to be quite weathered because they get a lot of rainfall and they're close to the coast. What happens is over time, you remove a lot of the soil particles just through the process of wind and water weathering in the soil. And so what you're left with is relatively low fertility soil in that case. So almost every soil that you look at is somewhat influenced or largely influenced by the climate within which it is as well. Good job. Go ahead and pass it over to. let's see, is it Colton?
Briley.
Okay, that's right, Briley. Okay, that's right. Thanks, Seth. And so also we have other biotic and abiotic factors. So Briley, what's a biotic factor and what's an abiotic factor?
Living versus non-living.
Yep. So living versus non-living. So any biotic factors are going to be anything, whether it be plant, animal, fungi, etc. Abiotic factors are going to be things like wind and rain and other weather events that may not be strictly listed in under these. And I thought it would be interesting here. I took a picture of some cows eating some grass in a field. I put 3 circles on here just to point out that within an environment, each of these is going to be influenced by the others as well. So what types of things are going to be influencing this tree in this picture, Briley?
The wind, the soil content, rainfall.
Good.
Fertilization, things like that.
All right, perfect. Great answer. So what effect does this tree have on, I guess, the cows and the grass?
It provides shade for them to sit, for the cows to sit under during the hot summer
Okay,
days.
so it provides shade. What evidence do we have of that?
The shadow.
Well, yes, good. The shadow and the fact that you've got a bunch of cows sitting down in there. Cows are really good at finding shade. What effects do the cows have on the trees?
They're gonna eat the bottom level of leaves.
Yeah, they're gonna eat some of the leaves off of it for sure. Are they gonna provide fertility for that tree? Probably, going back to the method of fertilization that we have here. Good. Peyton, what effect do the cows have on the grass?
They're gonna sort of maintain the population of that grass as well as provide fertilization.
Okay. Good. So it's going to be both consumptive and it's going to be fertility based. Would you say that it's all positive or all negative?
I'd say it's mostly positive.
Yeah, I'd say so. I'd say that it's mostly positive, but not 100. It kind of goes back and forth. But if it's well maintained, it should be more or less in balance. Is it Tully? Seth, that's right. I have it. All right. Well, yesterday I was calling everyone in my 3323 class Megan. So Seth in the back, I'm sorry, I'm gonna have to call you Megan so that we don't have both 2 Peytons and 2 Seths here at a time. Sorry about that, Seth. So I'm gonna ask you a question on the next one, I think. Or maybe the one after that. We'll see. Oh, actually, this is actually a reasonable question. We talked about rainfall more or less following vertical lines left to right. What pattern do you see with temperature in terms of the lines that we see?
Yeah, it's horizontal.
Yeah, it's more or less horizontal. There are variations within that, but more or less you see a north to south pattern within that temperature profile there. Good job. So, of course, that's also now going to bring up the question, why, if we're seeing vertical moisture profiles and horizontal temperature profiles, and then we're seeing a wedge shape that's essentially a combination of temperature and rainfall, what's going on? It's kind of a difficult question, isn't it? I'm sorry, it was just, it's question roulette. You happen to get the difficult question that we were building up to for like 10 people. This one shows it fairly well, I think. So I think I'll actually, yeah, this one is actually, I think the one that I was looking for that really shows the wedge. So you see this pattern where we move, we're able to get into more arid regions as we go north, and we're also expanding to the east here, going this direction. So why are we able to get away with a shortgrass prairie in Montana up here, whereas if we come straight down and we're in Arizona, that's just not happening?
Because it's colder in Montana.
Oh, that is exactly right. You can go ahead and pass it. Because it's colder in Montana. What actually happens is, I'm looking to see where I have ET in here. What actually happens is there are two factors at play here. Number one, temperature. Number two, rainfall. But what happens is, because as you get colder north, or as you get further north, it gets colder, you actually require less water to grow crops within that region, because the plants start really coming out of dormancy in Texas, maybe in February or March, and they start coming out of dormancy up in Montana, maybe in April or May, and then your season's done up in Montana by about September. And here in Texas, it's going to extend a lot longer. And so in the north, you're very temperature limited. And in the south, it's really more a basis of just how much water do you have over that period of time. So what we tend to see when we come back to this wedge shape here is that the reason that you see a relatively small region of grassland prairie in the south is because you just don't have enough water to maintain that the further west you go. And the reason that you see more of it as you go up north is that you're less limited by the temperatures or by the rainfall up in that region. Okay, so Eric, summarize that for us real quick. Why do we see this wedge shape occurring here?
Because of our temperature and moisture.
Good. On the exam, I'm going to give you points on that, but expand further.
We have a shorter season north and a longer season at the south. And then throughout that, going vertical, we have moisture change.
Okay, good. I'll give you credit for that. That's going to get you most of the points on the exam right there. So you've got an interaction of the moisture and the temperature, and you evaporate less water, or you transpire less water up north than you do in the south, so you can get away with less water. Great job. Yes, Briley.
So just looking at the trend, it seems to follow both continental divides. So do they have any play in this?
Oh, question. It seems to follow the continental divides. Do they have any play in this? They have a huge play in terms of both the rainfall, but also from an agricultural standpoint, as you get into the mountains, you tend to be able to capture a lot more rainfall or snowpack in the form of surface systems, such as a lot of times if you go into Idaho and Colorado and even New Mexico, and you'll see a lot of what we call palisades, which are just giant man-made lakes with dams on them, where you capture a bunch of water and then you use that water to irrigate throughout the region. So it does have a big play, both in terms of the temperature and the rainfall regime, but also in terms of our ability to, if you can capture the water and distribute it, you can grow things, whether it be cattle or crops, in the area that you otherwise wouldn't be able to grow. Great question. I don't know if I've done that justice with the answer, but you know, those are two of the major things that we tend to see relative to agriculture. Let's see, Peyton, remember what I said about Georgia, that the soil productivity wasn't too great? Okay, well, I at one point I said that. Help me out here. Which of these states is Georgia? I'm gonna move my cursor around and you tell me when to stop, okay? Right here? Ooh, close. Except I hate you because this is Alabama. And as a Georgia alum, I'm required by law to hate Alabama. But yes, you have good job. Georgia's right here. Are we, again, the darker green or blue, the more productive the soils are? What color are the soils in Georgia? Orange. So their productivity index is very poor relative to most of the rest of the state or rest of the nation. Lubbock is green, so we're not bad. We're not great, but we're not bad. What are these states up here with all this blue? So what's this one? And you can pass it if you want to, Elizabeth. What's this one up here? This one's got quite a bit of blue on it.
That was Wisconsin.
Good guess. Here's Wisconsin. Illinois. How about this one? Iowa. So a lot of our major Kansas, Iowa, Illinois, the states that we hear a lot about in terms of corn and soybean production, there's a big reason for that. They have good soils and they have good rainfall. And you know, if you can grow a high quality crop without a whole lot of inputs, you know, you're going to tend to grow quite a few crops up that way. And if you overlay the acres of land and farms as a percent of land area in acres, it follows pretty closely with our soil productivity index, which also follows fairly closely with our rainfall and our potential ET index as well here. How many of you had ever really thought in terms of where most of the agriculture is in the United States? All right, well, now you're thinking about it. Do you find this interesting? Do you find it interesting that the bulk of the production that we have, oh, hang on a second. I told you, anytime you see me going into paint, things are gonna start getting wild here. Boy, that's a big one. But if you take I don't know how to use this as well as I do like Photoshop or PowerPoint, but if you take this section right here in the Midwest, that's where the bulk of our farmland is in the United States. You can go ahead and pass it on if you want now. Actually, do you feel like you answered a question or do you feel like I just kind of answered it for you? Okay, so I'll ask you another question, Elizabeth. So why we always hear about how great the land is in California, but you don't see a whole lot of farmland in California. What's going on with that? Government. Yeah, that's certainly a big part of it. And that's, you know, it's, and again, I'm not here to criticize California, although, you know, you catch me on a crazy day and I will, but there are two big factors that are going on here. Number one, yes, Riley. Okay, yeah.
He seems more of a historical thing of, yeah, the Continental Railroad coming through, so everybody knew they were going to be shipping their cattle to Kansas, and so you would just meet in the middle, and so people would stay more towards the Central America.
Interesting concept. And so a lot of the development of the farmland through here was due to the migration patterns in the United States back 150 to 180 years ago. And there certainly is a big impact on that. Although I will say that Agriculture in California has tended to drop over time. And a big part of that has been a decrease in water and an increase in land values for other uses, and a movement to a lot higher intensity, higher value crops in California as well. But the Midwest has traditionally, number one, been a great place to grow stuff. And number two, it has been a great place not to do other stuff. And so it's tended to be a great area for farmland. Now, as was mentioned, migration patterns have a big influence on it. Anytime you get close to waterways, you tend to start to see, land usage toward agriculture disappear, because you tend to start to get a lot more transport and, other types of industries where you can actually move stuff rather than grow stuff. But, by and large, the biggest productivity areas, not only in the US, but also in Brazil and other countries that have a large agricultural output, tend to be in areas that 150 or 200 years ago would have been short grass prairies, because they tend to have high fertility, they tend to have pretty good rainfall, and many times that's the most productive use of the land in that area. And places near the coast many times have pretty productive land, but they're also attractive for other reasons, and so that land ends up getting moved out of agriculture just because they want to use it for something else. If we switch from general agriculture to forage agriculture, you tend to see three distinct regions. You've got the Pacific Northwest right here, you've got the southern plains right here, and then you've got the East Coast here. Most of this region in here tends to be in small acreage agriculture. Here we tend to have, a lot of cattle production. Here we have a lot of dairy production and also a lot of cattle production as well. But by and large, why don't we see more forage production in Illinois and Iowa, which we just said were great places to grow crops?
Is there not enough rainfall?
Oh, there's plenty of rainfall. You could grow great alfalfa in Iowa. What else can you grow really good in Iowa? Yes, Riley. Yeah, but look at Idaho and Montana and Wyoming. We've got quite a bit of good stuff going on here. So, certainly Iowa can't be too much colder. Peyton, and then Eric, and then Peyton. Oh, yep. Corn and soybeans are going to dominate because they're the money makers out there. You feel like he stole your answers? Okay, fair enough. But by and large, there are a few factors that affect where we tend to see forage production. Number one, it's got to be profitable compared to the alternatives. Number two, it's nice if it's in the same general regions as where we see cattle production. So, if you're growing something that you want to feed to cattle or to other types of animals, it's good to have those animals available to you as well. And so, let me see if I can pull up the cattle one real quick here. So here's where we see cattle and calves in the United States. Here's where we tend to see forages, and they track with each other pretty well, because one of the other challenges with forages is if you're trying to ship them, actually that's actually a good question. What's the problem with you're handing it back? What's the challenge with shipping forages, generally speaking?
Well, depend where it's going in the region, probably, because transportation costs could be a lot.
Okay, why are transportation costs a lot?
Well, I mean, you got labor, diesel, and given the state of the economy right now, everything has doubled within the past. few
Okay.
days. So like right now, I know hay is extremely expensive, especially in California and in other parts of the
Okay.
country.
Yeah, and so hay's really expensive right now. Transportation costs are a big deal. But you know, the patterns we're seeing here are not strictly patterns that have been caused within the last 24 months per se. What were the, and you've nailed it in terms of transportation costs, but why is it such a pain to transport hay as opposed to something else? Briley, and then any other comments on that question?
Storage.
Okay.
Especially in grain sorter, I mean, have people move grain bins.
Okay, storage.
Don't have enough storage to hold it.
Okay, yeah, so storage capacity is definitely going to be a big issue here. There's one other issue that we tend to run into with forages by and large in terms of transportation, and that is a real kicker when we're trying to move it, especially long distances, and that is, generally speaking, with forages, it's difficult to get them down to a density where they're economical to transport. So even if you're doing big round bales, they're pretty dense. When, you know, a big round bale is going to be what, about a ton, but it also takes up a lot of volume in that process. And so what happens is you're limited by volume as opposed to by weight. So you're carrying a lot of relatively lightweight things a long distance, and you're having to pay for the space, even though you're not moving the volume. And so transportation costs, and this is something with several ag commodities, not strictly just forages, but you tend to get beaten up by the fact that you're trying to move relatively low density products that are relatively low cost. You know, if hay is $200 a ton, which, I mean, a few years ago, $200 a ton of hay, we'd get really excited about it. But you know, that's 2,000 pounds of material and it's only worth $200. Now imagine shipping it 500 miles or 1,000 miles. You've just paid $3 or $4 off of that $200 just for moving it around. Everyone have a wonderful afternoon. Stay safe if the roads start getting nasty, and I'll look forward to seeing you on Friday. Any questions before you leave? All right, thanks everyone. Right, real quick before you go, let me make sure I've got names correct. I'm gonna miss one or two, so sorry. Jill, Peyton, Seth, remind me your name? Daisy. And then Eric, Peyton, Elizabeth, Briley, Brooke, Tanner, and Seth. All right, everybody have a great day, and I'll see you on Friday.